Hey, good morning, guys and gals, on this cloudy Thursday morning. Mr. Herr here. Hope everybody's healthy, wealthy, and wise on your end. Um, Today is our last new piece when it comes to probability. Specifically, we're going to talk about permutations and combinations. Hopefully, that's something that you've heard of before, but at the same time, I'm not going to assume that you know what either of those are. We'll talk about how to identify them. We'll talk about what makes them different, and then we'll try to apply it to statistic-based problems. It's going to be a little tricky because we don't have a handy-dandy calculator um, for us, but I did include a website on Schoology, a permutation combination calculator, so hopefully that makes things a little easier for you. Um, yeah, so that's where we're at. Um, Hopefully, like I said, the work level's been appropriate. Please let me know if you feel like you're getting too much, if you'd rather me do, two big videos a week as opposed to one every day. However you want this to look like, I want to meet you in the middle. Yeah, so that's where we're at. Without further ado, let's do this thing. Watch the breath. Hey, as always, this is a perfect time to pause the video, grab a piece of paper and a pencil, and follow along. So, we want to talk about permutations and combinations. Just specifically here, we're going to determine if it's a permutation or a combination and then go from there. The big thing is a permutation, order matters. So when I say order matters in a permutation, like if you're running a race, there's a huge difference between first place and last place. And I know some of you are saying, Mister, you'd be in last place, you're old and slow. You're not wrong. But there's a big difference there. Order matters. I'm trying to think of, typically I use race, like running races or car races as an example. But there's other scenarios, like if you're choosing a phone number, how you plug the digits in, order matters. Okay. Combinations, the flip of that, order doesn't matter. So what I mean by that is, let's say, and I think we actually talked about this in class a long, long time ago, but let's say that, somebody is giving away tickets to see a movie. It doesn't matter if you get the first ticket given away or the last ticket given away. Either way, you're a quote unquote winner. You're going to see the movie. The order in that scenario doesn't matter. If you are in a starting lineup for a ice hockey team, you have the goalie and then you have 5 other players. Well, as long as you're on the ice, it doesn't matter where you were selected as long as you're playing. Okay. So I'll really try to draw attention to that. All right, so let's do this thing. In a race of 10 horses, how many ways can the top 6 finish? Okay, well, ask yourself, does order matter? Well, yeah, they're running a race. First, second, third, the order matters here. So yeah, this is definitely going to be a permutation. Okay. Now, for those of you who have handy-dandy calculators, I'm going to show you something quickly, but you don't have to have this. I don't want you to panic. If you press, I'll clear this out. If you press the math button, and you go over to probability, PRB, NPR, that stands for permutation, and CR stands for combination. So I'll show you with each problem sort of how to set it up. And then I'll also show you how to do it by hand. So when you're setting this up with the calculator, you always say to yourself, all right, how many horses do I have to choose from? 10. That, whatever you're choosing from, goes on the left. And how many do I want? Well, I want ways the top 6 can finish. So you would actually type this in, 10 NPR 6, hit enter, and you'd have your answer. Now, if you're like me, well, when I was your age anyhow, you're probably saying, I don't have one of those calculators. Just think about it logically. How many different horses potentially could come in first? Well, potentially you have 10 choices. That horse crosses the finish line. How many potentially could come in second? Well, one already crossed the finish line, so then you have 9 options for second. You have 8 options for third, 7 options for fourth, 6 options for fifth, and 5 options for sixth place. So that's how you could do this by hand. And then what you need to do, folks, is you multiply all these options. 10 times 9 times 8 times 7 times 6 times 5. I know that's a ton of options, but it's just multiplication. Whether you use the calculator, whether you use it by hand, or there is that internet calculator that I included in the folder and I'll include in the updates. Either way, you end up with 151,200. Okay. Letter B, we'll set it up the same way. In next week's Daytona 500, helps if you can speak, Mr. Herr. 44 cars will race. How many ways can the top 3 finish the race? Well, it's a race, so that means order matters. 44 permutation 3. That's how you would type this in the calculator. Doing it by hand, we have 44 cars that could potentially come in first. 43 cars, because one already passed, that could potentially come in second. And lastly, 42 cars that could potentially come in third. Whether you use the calculator by hand or the online calculator, either way, we have 79,464 ways that there are different top 3 finishers. Okay, that's a lot of different variability. That's why, not that I condone this, but that's why betting on races is, the house always wins, because look at the odds of getting it right. Okay, on to C and D. These are a little more complicated. On a basketball team, there are 14 players. How many different combinations, there's a word that gives it away, of lineups are there on the court at once, assuming 5 players play at once? Okay. It doesn't matter if you're chosen first to be on the court or 5th to be on the court. You just want to be on the court. Therefore, order doesn't matter. So this would be a combination. It would look like 14, choose 5. And we do that in our calculator if you have it. Now, if you're like me, you're probably saying, man, when I was, I don't have one. So, and I was the same way when I was your age. The initial part of this looks the same. Okay, so we will have 14 for our first selection, 13 for our second, 12 for our third, 11 for our fourth, and 10 for our fifth selection. The difference, though, because order doesn't matter, the difference is we have to divide. And you might say, well, mister, what do we divide by? And this one's going to blow your brain up a little bit. It's how many we're choosing. We take the factorial of that. If you're saying that's a big word. In other words, since we're choosing 5, we'll take 5 times 4 times 3 times 2 times 1. That's what we divide by. This is called a factorial. Okay. I know doing this by hand is going to be a little bit of a pain. Once again, that's why I included the combination and permutation online calculator. Okay. But when you run that, multiply your numerator divided by your denominator. Make sure you include parentheses when you're typing that in, folks. You end up with 2002. Okay. Letter D, Old Country Buffet. They offer 30 selections on their dinner line. If you have a 5-compartment plate, how many different combinations of plates can you make? It doesn't matter if you choose chicken wings first or if you choose it 5th, as long as it makes it on the plate. You know what I'm saying? So this is a combination, specifically 30 choose 5. And if you're doing it by hand, it would look like 30 times 29 times 28, 27, 26. Notice that we can do that because it says you don't repeat your selections.
Because it's a combination, we must divide. Since, once again, and it's probably a bad choice on mine, by choosing 5, that means we'll take 5 factorial, also known as 5 times 4 times 3 times 2 times 1. When you type this in, make sure you include parentheses if you're doing it by hand. But when we do that, we end up with a potential of 142,506 different plate combinations. I like to eat, but even I have my, my limits. I was going to get to number 2. Honestly, though, without the calculators, that's going to be almost impossible. So I'll expand upon our homework a little bit, and this is what we're going to be looking for. All right. Hopefully you're good to go, guys and gals. Stay healthy, wealthy, and wise. Peace.